In this lecture video, we are going to talk about release testing. Now, release testing is the process of testing a particular release of the system that is intended for use outside of the development team or in the user's environment. Normally, the system release is directed towards customers and users. If you consider a complex project, the release could be for other teams that are developing the related systems for this system. And for software products, the release could be for product management who then prepare it for sale. The primary goal of release testing process is to convince the supplier of the system that it is good enough for use. If so, it can be released as a product or delivered to the customer. Release testing, therefore, has to show that the system delivers the specified functionality, performance, dependability, and so on, and that it does not fail during normal use. It should take into account all the system requirements, not just the requirements of the end users of the system. Release testing is also known as the black box testing process. Here, tests are derived from the system's specification. The system is treated as a black box whose behavior can only be determined by studying its inputs and related outputs. Another name for this is functional testing, so called because the tester is concerned with functionality and not the implementation of the software. Black box testing or functional testing means the implementation or the code is hidden from the tester. The tester will certify if the system is fit to use only based on the observed outputs. That is, a system is supposed to behave in a particular way when given a particular set of inputs. If the system behaves in the expected way, the system passes the test. You do not have to go through the implementation code or any other details of the system. Merely the input and the expected output will certify the system as fit to use. There are two important distinctions between release testing and system testing during the development process. A separate team that has not been involved in the system development should be responsible for release testing. System testing by the development team essentially focuses on discovering bugs in the system or defect testing. The objective of release testing, however, is to check that the system conforms to its requirements and is good enough for external use, also called as validation testing. Let's now talk about requirements based testing. A general principle of good requirements engineering practice is that requirements should be testable. That is, the requirement should be written such that a test can be designed for that requirement. A tester can then check that the requirement has been satisfied. Requirements based testing, therefore, is a systematic approach to test case design where you consider each requirement and derive a set of tests for the requirement. Requirements based testing is validation rather than detecting defects. That is, you are trying to demonstrate that the system has properly implemented its requirements and is delivering what it is supposed to deliver. Let us consider the related requirements for MHC PMS, which are concerned with checking for, say, drug allergies. Now, if a patient is known to be allergic to any particular medication, then prescription of that medication shall result in a warning message being issued to the system user. If a prescriber chooses to ignore an allergy warning, they shall provide a reason why this has been ignored. To check if these requirements have been satisfied, you may need to develop several related tests. Firstly, set up a patient record with no known allergies. That is, prescribe medication for allergies that are known to exist. Check that a warning message is not issued by the system in this case. The second test would be set up a patient record with a known allergy. In this case, Prescribe the medication to that the patient is allergic to and check how the system behaves. Does the system issue a warning? Another test case would be set up a patient record in which allergies to two or more drugs are recorded. Prescribe both of these drugs separately and check if the system is issuing a warning for each drug. Another test case would be prescribe two drugs that the patient is allergic to. Check that two warnings are correctly issued. Another test case would be prescribe a drug that issues a warning and overrule that warning. That is, ignore the warning. Now check to see if the system requires the user to provide information explaining why the warning was overruled. You normally have to write several tests to ensure that you have coverage of the requirement. You should also maintain traceability records of your requirements based testing, which link the test to specific requirements that are being tested. Let's now talk about another type of release testing, that is scenario testing. Scenario testing is an approach to release testing where you devise typical scenarios of use and use these to develop test cases for the system. A scenario is a story that describes one way in which the system might be used. Scenarios have to be realistic, and real system users should be able to relate to them. If you have used scenarios as part of requirements engineering process, then you'll be able to reuse the same scenarios as testing processes. These are a few attributes listed here for good scenarios. A scenario test should be narrative, a narrative story that is credible and fairly complex. It should motivate stakeholders, that is, they should relate to the scenario and believe that this is important that the system passes this test. Scenario tests should be easy to evaluate. If there are problems with the system, then the release testing team should recognize them. Let's now take a look at a usage scenario for the MHC PMS. You can read through the scenario given in the box, where Kate is a nurse who specializes in mental health care. Her responsibilities include visiting patients' home, check their treatments, check the effectiveness of the treatments, and make sure they're not suffering from any side effects of medication. So Kate visits the homes assigned to her, logs every user summary, the side effects that have been observed, and then comes back, returns to the clinic, uploads all the records of patients visited to her database. Now let's consider testing a few of the features of MHC PMS in this scenario. First one, authentication by logging into the system. Second test would be download and upload of specified patient records to the laptop. Third one would be the schedules of home visit. The fourth test would be encryption and decryption of patient records on a mobile device. The next test could be record retrieval and record modification. After that would be links with the drugs database that maintains side effect information. And the last one would be the system for call prompting. So given this scenario, there could be a few tests that are designed to identify any drawbacks or any limitations of these scenarios. So if you are a release tester, you will run through this scenario, playing the role of Kate and observing how the system behaves in response to different inputs. As Kate, you may make deliberate mistakes, such as inputting the wrong key phrases to decode records. This checks the response of the system to errors. You should note if the system is too slow, if it takes too long to encrypt a record, and so on. So when you use a scenario-based approach, you are normally testing several requirements within the same scenario. Therefore, as well as checking individual requirements, you're also checking that combination of requirements do not cause problems. Let's talk about the third type of release testing, performance testing. Once a system has been completely integrated, it is possible to test for emergent properties of the system. These system properties may include performance of the system, how reliable the system is, and so on. Performance tests have to be designed to ensure that the system can process its intended load. This usually involves running a series of tests where you increase the load of the system until the system performance becomes unacceptable. Performance testing is concerned both with demonstrating that the system meets its requirements and discovering problems and defects in the system. Experience has shown that an effective way to discover defects is to design tests around the limits of the system. In performance testing, this means you are going to stress the system by making demands that are outside the design limits of the software. This is known as stress testing. Let's consider you are testing a transaction processing system that is designed to process up to 300 transactions per second. You start by testing the system with fewer than 300 transactions per second. You then gradually increase the load on the system beyond 300 transactions per second and continue doing this until it is well beyond the maximum design load of the system and the system fails. Now, this type of testing has two functions. Firstly, it tests the failure behavior of the system. Circumstances may arise through an unexpected combination of events where the load placed on the system exceeds the maximum anticipated load. In these circumstances, it is important that the system failure should not cause data corruption or unexpected loss of service to the user. Stress testing checks that overloading the system causes it to fail soft rather than collapse under the load, or gracefully degrade rather than suddenly stop functioning. Secondly, it stresses the system and may cause defects to come to light that would not normally be discovered under regular or normal circumstances. Although it can be argued that these defects are unlikely to cause system failures in normal usage, there may be unusual combinations of normal circumstances that the stress testing will discover. Stress testing helps you discover when the degradation begins so that you can add checks to the system to reject transactions beyond this stress point. So, this was about release testing and the three types of testing, that is, requirements based testing, scenario testing, and performance testing.